Here we're going to create a video to demonstrate to you how to create a logic label fine estimate machine from scratch that uses the Odometry service. This is the design of the machine. I'm going to be inside where we've been working, in Downloads, Catkin Workspace, and I'm going to put this command. Notice that this is the name of my new package that I'm going to host a machine in ROS node for a machine. Because of C++ and messages is that I put this here. Because it's a logic label fine estimate machine, I will mention that depends on LLFSM and LLFSM. And because we're going to listen to the Odometry service is that it depends on the Odometry service. Once I create it, I go to Odometry tester machine, okay, and here I'm gonna make the directory machine like we've been doing for all machines. Now the trick I'm gonna show you today is that I'm gonna create the machine using my edit. I'm gonna go to New, I'm gonna go to Downloads, Catkin Workspace, Source, Odometry tester machine, okay, and we're gonna call it the name of the package. Otherwise you have problems with the Catkin make. So there's an Odometry tester machine, okay, and now we're gonna also use another trick, which is to run another instance of my edit, and I'm gonna open some of the very early machines. So I go to Downloads, Catkin Workspace, Source, and ROS Wall. Let's go a bit, one of the first one that use sensors, because I'm gonna copy that part of the initial state and modify it a bit. So we can see it. I bring this down. I'm gonna copy all this, and I'm going to bring it into the initial state of the new machine. I'm going to modify it. Something very similar that you see here. Here's the name of my node. This is the service that I'm going to use. How do I know this type? I can run ROScore. You should run in every machine the bell setup bash so that you can test messages. Now you see it running, and therefore I should see that it exists. There it is. So now I can do info to find more information about it. Note it's called Odometry service. So that's what is going to go here. All right. And information about it. Here is the type. So that's how we gonna do those types. Okay, so let's save the state and save the machine, and we're gonna proceed to compile this machine. To make sure we're in the right track, we're gonna compile now with just one state and then build up progressively. I have a machine here, so in order to compile it, I need to use the script to build machine. Remember that I have one in ROS blind turtlebot machine setup shell. We copy that one here, and so we can run the setup on this machine. Now we look at the CMake created by the creation of the package, and it shows that it depends on Odometry service. So we need this find. We open the suggested, because the suggested uses defaults for this, generic to a machine, but this machine in particular depends on Odometry service, but it creates all the compilation rules. So now we copy the suggested into the CMake list, run catkin make. Now catkin make is going to run and it gives us a few errors, in particular that it doesn't know about these guys. Right? There's no way to know about this type if my includes are empty. This is the machine we had before. And if we look at the includes here, I'm gonna copy these includes, cancel that, open the includes in the machine that I'm constructing. We're gonna take this away because we are not listening to a topic, and we need to change this. So we need to change to what is going to be our service. So here you see I have changed what is going to be our service. So I save. Because I changed something significant, I need to run the setup again. I need to copy this into the suggested. Then I need to copy the suggested into this make list, and we're ready to make again. So I get errors again. What are the errors? Well, the errors are things like I don't know this variable. Of course, because in variables we don't have declared any variables. Check the other machine for what type of variables does it use. Let's look at the variables that it has. A handle or handle is odometry node. Open the variables. The type is correct. Odometry, no. What other variables do we need? We need our client and we need our service. Let's look at the variables here. So remember the client is a service client. So I'm going to copy that one. And that was the client. We also need, and this one is our service. Save the machine. We need to regenerate the machine. We didn't create any states, so I'm just going to run the setup script. I don't need to copy the suggested, and then I'm going to build again with catkin make. We have a machine that has compiled and would run and has a single state. Now it doesn't do anything much interesting, so we need to go back to our diagram. So let's add the state weight. We do add weight, nothing to do on it. I'm gonna also create the state end for Ross OK. Create print odometry. Print the values that we read on the survey. What sort of transitions do we do? We can go to the other machine. Let's say it's state turn right. And we look at transitions. And I'm going to copy this value so I can do transitions here. For example, like here, I add a transition. The target state is end. I add that one. Let's go to the state initial. At the moment, it doesn't have transition, so let's add a transition to the end state from initial. Not Ross OK. I always double save here. Now the next state is wait. Do we have transitions out of wait? No, so we add a transition to end. I'm going to go and make sure that my other state print odometry has a transition to end. we need to do is go to the state wait, add a transition to the state print odometry, and it's client.call service. This will be true if we were able to connect to the service, save the state, save the machine. Did we change the machine structurally? Yes, we did. Besides the setup, we also need to redo the CMake lists, as the new suggested has code of the new transitions that we built. So the machine changed structurally. There's new states or new transitions. We have to rebuild the CMake list for the machine. Time to compile. I believe we have a complete machine. What do we need? Here is where we launch the robot. Key teleoperation. So let's see if I can go forwards and stop it. Start the odometry service. Here we need to run the machine. Remember, you copy the library compile into the Linux of the folder invoke LLFSM. Is stuck in initial. Why would that be? Well, let's look at our machine. We're gonna stop everything so that I have some CPU cycles here. So I'm killing gazebo, I'm killing the odometry service. So the machine got stuck in initial. There's no transition, so we forgot a transition. So we need to add a transition to wait, and it's gonna be after milliseconds 200. And remember, we need to build, and because we added a transition, we need to rebuild the CMake list. Copy the fix suggested into CMake list, recompile, and after I recompile, copy the recompile machine, launch the robot, launch the keyboard, launch the service, and we launch the machine. And now it's printing the odometry once. Oh, what happened? I forgot another transition. We need to get back from initial to wait to print, and then it wouldn't get back. So we need a transition from print odometry back to wait. Here's our machine. Let's go to the state print odometry. We look at the transitions here, and there's only the transition to end. Add a transition, back to wait, and this transition we're going to do after milliseconds, so we do it 3 times a second. Save the state, save the machine. Again, we added a transition, so that's a structural change to the machine. Because of the structural change to the machine, we're gonna run the setup again. We incorporate that into the suggested we just built. The suggested replaces the CMake list. Compile again. Here where we run, remember I have the command that copies the compile machine into where CLSM needs it. So we're ready to run it again. Let's run the simulation equivalent to starting our robot. We want the way to move the robot around so we can actually see, so we can, for example, move it forward and stop it. We need the odometry service, which converts the odometry topic into a service so machines can use it. So there's the odometry service running. We're going to run the machine. No change in the odometry, but if we make the robot move forward, the odometry is changing and the machine is reflecting that. Let's stop it, and the odometry is not changing, although we are moving in the machine. So you have here a machine that reads the odometry, and now it could make decisions on the odometry.